In this video, I will show you how you can use Arduino to not just receive, but also send remote control commands. In order to receive the commands, I will use the T-sub receiver that I already used in the last video. Now, sending a signal is a little bit more tricky, because now we need an infrared LED. The thing with this infrared LED is, if we look into the datasheet, it has a forward current of 100 milliamps. Arduino Uno revision 3 only supports 20 milliamps. So I will use a transistor to amplify my signal. So this is what the schematic will look like. My infrared LED typical forward voltage is 1.5 volt and the forward current 100 milliamps. And I will use an NPN transistor connected to ground right here to drive this LED. And now we have a voltage drop across the LED and we have a voltage drop across the transistor here. Even if it's turned on, we have a voltage drop across the transistor, and this voltage drop, you can find it in the datasheet. It's called collector emitter, because this is the collector, this is the emitter, this is base, VCE, saturation. I'm using a BC337. In my case, this is 0.7 volts. So now we have 1.5 volt across the diode and 0.7 volt across the transistor, which makes it 2.2 volt in total. Now we will supply this thing with 5 volts. So the question is, how big is this resistor right here? We can use Ohm's law. So resistance equals voltage divided by current. We have 5 volts, but we need to subtract 1.5 volts and 0.7 volts. And the current is 100 milliamps. So it is 0.1 amps. So this gives us 2.8 divided by 0.1, which results in 28 ohm. Great. The base needs a resistance because this transistor acts as amplifier. And you can find the DC current gain right here in the datasheet. It is between 100 and 630. So the minimum amplification is 100, which means if we want 100 milliamps at the output, and we need 1 milliamp here, because the amplification is 100 minimum. Now, if we put in more than 1 milliamp, or the amplification is bigger, it doesn't really matter in this case, because our resistor right here limits the current. So we can't really get more than 100 milliamps. It's not possible in this case. So this right here is a minimum. And so the question is, how big should this resistor be? And this resistor is again voltage divided by current. In this case, how big is this voltage right here? Well, we have 5 volts right here. We have this voltage drop, and then we have one more voltage drop here. And that is this one is called VBE saturation. And we find it inside of our datasheet. Yeah, base emitter saturation voltage. It is 1.2 volts. 5 volts minus 1.2 volts divided by 0.001 amp. Yeah, this results in 3.8 kilo ohms. And this should be our maximum resistor, because if the resistor is a little bit smaller, there's a little bit more current flow, and that's fine. And in my case, I don't have a 3.8 kilo ohm resistor, so I will pick a 3 kilo ohm resistor. That's fine. You can also use something a little bit smaller. Doesn't really matter. We have the diode, we have the transistor, and there is one more thing that I don't have, and that is a 28 ohm resistor. I will use a parallel circuit instead. I have 50 and 62 ohm, and so instead of one resistor right here, I will use two resistors like this in parallel. Now this is a trick that you can always use. If you don't have a specific value, then you can mix resistors to get to the value. If you use a resistors in series, it's very easy. You can just add the values. So 10 ohm plus 10 ohm is 20 ohm, right? But if you use it in parallel, then the total resistance is smaller than every single one of them. If you use two that are the same, so if you use 50 and 50, it is exactly half of that. So it is 25. But in this case, we need 28, and 50 ohms times 62 ohm divided by 50 ohm plus 62 ohm. Now this gives us approximately 28 ohm. So that's almost perfect. It's a little bit less, so we will get a little bit more current, but that's fine. One last thing. With the diode, you will see one flat side of the LED. And this means this is the cathode, and this is right here. Let's connect everything together. How does it look for the transistor? Let's look into the data sheet. One. Yeah, great. What is one? Okay, this is one. So the transistor looks like this. 1, 2, 3. And the first one is collector, then we have base, and then we have emitter. We will use this resistor right here and connect it to the base of the transistor. And this right here is our signal. And I will connect the signal to, let's say, pin 3. Pin 2 is our input and pin 3 is our output. The emitter of the transistor will be connected to ground, and I will use this ground that we already have right here. Like this. And then we can add the diode. So the flat side of the case right here, flat side, needs to be connected to the transistor. Like this. And then we need the two resistors. So one resistor, another resistor in parallel. No, not yet. Yes, now they're perfect. And then we need to connect it to 5 volts. So this right here to our 5 volt signal right here. And this is it. This is how we can send signals. Awesome. Let's look into the software part. So first we need to take a look at the signals in order to then emit it ourselves. I'm using a library that is called IRremote. So if you don't have it already installed, click into the library manager and then insert IRremote. And then make sure that this one is installed. And if it's installed, you'll find examples. So in File, Examples, IRremote, Tiny Receiver. I already used it last week. We need to enable the ONKYO protocol because I have an ONKYO remote right here. Now we can have a look at the signals. So I will write it down somewhere. Let's open a new text file. I will start with BENQ. On is off is this signal right here. And ONKYO, it only has one button, so we can just use this one button, either to turn it on or off. So this is our button. And then it also sends repeat, which is interesting. When I keep it pressed, otherwise it will turn on, off, on, off, on, off, on, off. And I guess that there is a flag that indicates that this is a repeat signal. Whatever, let's see how it works. All right, so this is tiny receiver. And now I would like to tiny send. So let's go to infrared remote, tiny sender. So one question is our infrared send pin. It is inside of pin definitions and more. So let's see what it is. Perfect, infrared send pin is pin 3. So I did everything right. I connected it to pin 3. Now here we see a new data type that we haven't seen so far. This is an unsigned integer with 8-bit. So it's basically byte. It's harder to read, but it's a better way to define data types because they're not platform dependent. On all CPUs, they are unsigned integer 8. While integer, for example, can be interpreted differently on different platforms. That's a big problem. Sometimes it's 16 bits, for example here. Sometimes it's 32 bits, for example on the ESP. And sometimes it's 64 bits, like on a desktop PC, right? Let's see what happens. I will just try the demo code. Boom. Okay. Can we see something with the camera? Most likely not. Okay. So how should we know if it's working or not? I think I will use a second Arduino Uno. So this Arduino is now powered by this Arduino. And we can use this to send signals into our receiver, hopefully. All right, and in this Arduino, I will use the tiny receiver. Awesome. So you can see we are receiving something. So now we know that the hardware works. And so I will switch back to my sender. And here comes your exercise. I would like to send a serial command to my Arduino. 0 is for turning off both of them, and 1 is for turning on both of them. So we have 0 begin. I will do something like this. If serial.available, then my character call command equals serial.read. If command equals 0, and this is a string, so we need the single quotation marks. Turn off. Yeah, and else if command equals 1, then turn on. Yes, and so we will put the sending stuff into these two spots right here. We need to repeat the signal a few times to make sure that the receiver gets it. So let's do while repeats is smaller than 10, do it. Yeah, so I will use this right here. So my first address is 0x3000. 3000 doesn't fit into 8 bits, so we need this. And this command also is bigger than 8 bits. So I will remove them. Perfect. So this is our on signal, but we need off. Yeah, this is off. S repeats, while S repeats is smaller than 10, we will increment S repeats and delay. Let's use 20 milliseconds. Yeah, and I don't know what exactly this one requires, which protocol this requires, I don't know. I think it is also an ONKYO, but let's see. So let's try with ONKYO. Let's try it with ONKYO. And we, of course, need ONKYO. So yeah, this is our command and this is our address for the ONKYO. So we send the BENQ address and the ONKYO address and the BENQ command and the ONKYO command like this. I will comment out all of this. And we will do the same thing for the on command, but we need some slight modification, and that is on is this command right here. Yes. I will add some information right here. Serial print, yeah, let's do println on, and serial print off. So if I send 1 on, so this looks about right. Yeah, let's try it out. I will remove this stuff and we'll put it to the field test. All right, so let's see if it works. It doesn't work. I had to tweak the values a little bit. It wasn't easy. So I have a for loop that has 10 repeats with 5 milliseconds in between the commands. And for the BENQ, I don't send the repeats. So let's see if it works. Let's upload the code. So here you can see the BENQ and here you can see the ONKYO. And I will send the command to turn both of them on. So as you can see, both of them turned on. And now I can send the command to turn both of them off. Yeah, for some reason I had to use 8 milliseconds, but now both of them are turned off. If this video was helpful, please like and subscribe to this channel if you're ready to dive deep into the world of Arduino. Thank you for watching. See you in the next lesson.